Start. Sugan, you can start.
Good evening to one and all present here. Work hard to achieve your dream, or others will hire you to do theirs. On behalf of Nehru Institute of Engineering and Technology, Coimbatore, and on behalf of Department of Mechatronics Engineering, a warm welcome to all gathered for this national level webinar on an insight into electric vehicle configurations and its motors. I thank our management and our beloved CEO and Secretary, Dr. P. Krishnakumar sir, for supporting us to conduct this webinar. I thank him on his absence here. And I thank our principal, head of various departments, faculties, and all participants joined for this webinar. Now, I invite Dr. M. Maheswaran, Associate Professor, to give a welcome address and to give a brief introduction about the resource person.
Thank you, Sugan. Good evening, everyone present here. On behalf of NGI, NIT Management and NIT Principal, I welcome everyone. Now I introduce the resource person of the webinar, Dr. B. Adhavan. Completed PhD in 2014 in Anna University, Chennai. He published 10 research papers in international national journals. He is a recognized supervisor for guiding PhD in Anna University. He was one of the member of task force team to set up the Center for Transportation and Vehicle Engineering in Adama University, Ethiopia during 2015 to 2017 and worked in electric vehicle projects of Ethiopian government. Under the book title Applied Electromechanical Devices and Machines for the Electric Mobility Solutions, he wrote the book chapter Permanent Magnet Synchronous Machine Drives. Under the book title Direct Torque Control Strategies of Electrical Machines, he wrote a book chapter on the topic Torque Ripple Reduction in DTC Induction Motor Drives. Received technical grants, total amount of 15 lakhs including India and abroad. He has 17 years academic experience inclusive of 12 years of research experience. His area of interest includes special electrical machines, controls, electric vehicles, power electronics and drives, embedded controls, and automation in energy management. He also serves as a reviewer for Journal of Vibration and Control, SAGE Publications, UK, IET Power Electronics. Dr. B. Adhavan currently working as Associate Professor in Department of Electrical and Electronics Engineering at PSG Institute of Technology and Applied Research, Coimbatore, Tamil Nadu. Thank you.
Thank you, sir. Now, I invite our chief guest for today's webinar, Dr. B. Adhavan, Associate Professor, Department of EEE, PSG Institute of Technology and Applied Research, Coimbatore, to take over the session on the topic An Insight into Electric Vehicle Configurations and its Motors.
So, good afternoon to one and all present here. Indeed, it's a great pleasure for the opportunity given to me. I thank Sugan and as well as Dr. M. Maheswaran for the introduction. I thank you one and all present here, and let us go into the session. So the topic I will present now. Just check out the Is it visible? Is it visible in the screen? Can anyone open up the unmute and please answer? Is it visible?
Visible, sir.
Yes.
Visible.
Yes. Just a minute. Okay, so today's topic, I will start my presentation. Okay, I'm ready with everything. Okay, so an insight into electric vehicle configuration and its motors. So at the outline, what is the presentation overview? Let us check out. A need for electric vehicles, then history of electric vehicle, then present trends in the electric vehicles, then electric vehicle types, that is the configurations, then basic operation, and what are all the motors used in electric vehicles, and the best suited motors comparison, that is a permanent magnet synchronous motor and a BLDC motor, and what are the major challenges in the electric vehicles. This is the outline of the presentation today we are going to see. Anyhow, it is a very vast topic. It is a ocean. Nowadays, the electric vehicle is a ocean. Anyhow, we will try to cover whatever it is possible in the time given frame. Okay. So why we require electric vehicles? So the problem of the conventional vehicles are, you can just check out, that is air pollution and the noise pollution. So the transportation causes 27% of greenhouse gas emitted is only through the transportation. So that means you check out the climatic change compared to the previous century and this century. So from 1900 to 2000, they are telling that to 2 degree the global warming has increased. This is actually global warming is because of these greenhouse gases. These greenhouse gases emitted from our from our vehicles, from our conventional vehicles. So the conventional vehicle emits greenhouse gases, and as well as if you see the other gases are like nitrogen oxides, NOx gases. Okay, NO2, NO, and N2O. All those gases are exhibited. That is called NOx gases. Okay, then carbon monoxide. It is also one of the big problem. Carbon monoxide. It is a major pollutant. If you inhale carbon monoxide, definitely what happens to our lungs is lungs get damaged off. Even carbon monoxide, if you inhale too much, you may die immediately. So that is another issue of the conventional vehicles. And sulfur oxides also emitted out from the from the conventional vehicles, and also unburnt hydrocarbon. So if you compare the efficiency of any diesel passenger, it is only like in the order of less than 40%. So if it is less than 40%, remaining 60% is unutilized and it is exhibited as a unburnt hydrocarbon. So you cannot able to have a control over it. It is simply wasted in the air. In an unburnt hydrocarbons come out in the air. And of course, regeneration is not possible during braking. So when you brake, it is exhibited as a heat. Okay, it is exhibited in the brake drum. The energy, that is, it has a heat energy, it is exhibited. And if you see while operating the engine, a petrol engine or diesel engine, it also emits heat. Lot of due to combustion, it emits heat. It takes power in also standstill condition. When the vehicle is at standstill condition, just turned on, and it is at standstill condition, means it also takes power. Power means it consumes a petrol or a diesel or a gas for running of the engine. So then complex mechanism with gear and wear and tear arrangement. Okay, gearbox, it's a complex mechanism, that is 1, 2, 3, 4 gear system. Is a complex mechanism, and wear and tear of the parts are also more. And the main important point is declining in fossil fuels. You need to for the fossil fuels, otherwise you cannot able to travel from one place to the other place. So these are all the problems associated with the conventional vehicles. That is nothing but the drawbacks of the conventional vehicles. So we require electric vehicles. So what are the advantages of electric vehicles? No emission, there is no that is tail pipeline outside, no emissions, so it doesn't require gas, petrol, or diesel. Then its effective running cost is cheap. Okay, the running cost is cheap because it uses electricity, and electricity, if you charge a battery, it will be less cost compared to the running cost of the conventional vehicle, the petrol or diesel. Nowadays you can watch the petrol and diesel prices are they are hiking, day by day. It is they are going up. So you need to find and also it is depleting maybe in another 30-40 years, maybe in 2100 it is completely depleted and the cost will be very high. So you need to change over to some other alternative. So the best alternative is electric vehicles, and also less number of parts in electric vehicles, so low maintenance, and it is costly. Quite the drawback of electric vehicle is it is costly. So there is some payback period. You need to wait for say 5 years or something like that, such that the running cost is less. So the running cost will pay back to you maybe after 5 or 6 years, something like that. And if you compare the electric and the gasoline cars, no tailpipe emissions in the electric, and the utility company means you need to ask for the electricity companies only. Okay, then it is very close to us, because in every country generates its own electricity, and the range, okay, it can travel is 100 plus range. It can travel 100 plus mile range. That means like 160-kilometer range it can travel for a full battery. For one full battery, if it can travel up to 160 kilometer in kilometers, and if it is in mile, it's 100. And it takes more hours to recharge. If you take a battery, if you want to recharge, it takes more time compared to the refueling of the gasoline. So it takes only a minute. Go to a petrol bank, just within 2-3 minutes you will fill off. But whereas a battery, if you want to charge, it takes more time. And what is its kilometer per mile? What is the cost? It is only 1 rupee. Okay, 1 rupee is kilometer per mile. Whereas if you compare the gasoline, that is the petrol or a diesel type, if you check, it is almost 20 rupees per mile. So and also you need to depend upon the organization of petroleum exporting countries, that is OPEC countries, because these OPEC countries only produce the petrol or diesel, and it is to exported to the countries which doesn't have the resource, oil resource. So India is a very big importer of oil. Okay, very big importer of the crude oil. So you need to rely on them. Only like 4 or 5 countries in the group, like Saudi Arabia and Iran, Iraq, and Venezuela and Oman. Only very less number of what you call countries are there. Only you can find the oil resources, and it exhibits greenhouse gases also. So it increases the overall temperature, and it takes minutes to refuel. Only one advantage is quick refueling, whereas if you can, and also the other one is 300-mile range. For one petrol tank, if you fill, it can cover a 300-mile range. 300-mile range is 300 into 1.6. Of course, like 500 kilometer, you can cover in one refill of gasoline, that is a petrol. When you compare both, okay, the drawbacks, if you find out the drawbacks, it emits greenhouse gases, the gasoline type, and you need to depend on OPEC countries, and the cost is also, running cost is high, whereas the running cost for electric is less, so it is only 1 per mile. Let us check out the history of electric vehicles. Okay, so it is not new. It is not, the electric vehicle is not new. It is very old. Almost you see it in 1835, the first electric tricycle was built. Imagine, now we are in 2020. Almost like there is 165 plus 20. Almost we are 185 years old technology. Already it was present. Okay, but why it doesn't get popular enough? That is the point. So advances in IC, internal combustion engine, technology and petroleum infrastructure. In that olden days, it is very hard to take the petrol from the land. You need to dig a very lengthy hole. It is or a lengthy canal, and it is very difficult. It is very difficult to take petrol or the crude oil from the underground. That technology was inferior, but in 1900s only this technology get a very good hype. So it declined until 1835 to 1920. The electric vehicles were working, and it has been running in our streets. Running in our streets means not in India, in foreign countries like Britain and America and Canada. And decline, its decline started in 1920 and disappeared completely in 1935. So in 1935, because in 1920 the IC engine technology was blooming up, and it is very easy to take the petrol from the underground with borewell technologies. All those things came into existence. So electric vehicles disappeared in 1935. But what happened in 1970s, energy crisis renewed in the interest of electric vehicles. Because the energy crisis, you don't get the petrol often cheaper, and it is becoming day by day, it is costly. People wanted to move into alternative, and also it was emitting greenhouse gases. The global temperature was increasing, so they just shifted their focus towards the green technology, that is electric vehicles. Yeah, you can just watch over some of the olden days electric cars which was produced by Siemens in 1904. You can see, and you can see the Thomas Alva Edison with his car which was developed by Detroit Electric in 1907 to 1939. It was working 1907 to 1939. And also you can see the other types, okay, and treble horn 1902 to 1919 it was running, and the Henny kilowatt, you can see in 1961 they produced, and Vanguard Sebring city car, you can see the type. These are all completely electric. And Saturn EV1 developed by General Motors. It's very recent, you see, in 1996. A lot of companies have produced it, but I just took only samples, okay, samples of it. And nowadays, just 10 years back, 10 to 12 years back, you can see Chevrolet Volt and Tesla Roadster. This is a very big hit. These two cars was very big hit of electric vehicle. It was a lot of people were buying, and they were using it. It was a big hit, Chevrolet Volt and Tesla Roadster. What are the modern electric vehicles right now? All the companies are focusing is, you can see Ford Focus Electric, Tesla Roadster, and Mitsubishi IMI EV, and Koda Sedan, and Nissan Leaf, Tesla Model S, Honda Fit. So these are all modern electric cars which is present, and it is developed in foreign countries. If you want, you can also able to import, and you can work on it. Okay, you can just ride an electric vehicle. So present day trends in all the segments of the passenger segments as well as sports segment, sedan class, compact, and trucks. In all the segments nowadays, electric vehicles are released. Just check out here in the sports and luxury model. Tesla Roadster is one, and Porsche 918, Audi and Fisker. Okay, then Cadillac XTS, Volvo, and the Tesla. So you can see in sports luxury model how many cars are released around the globe. And in the compact mini type, you can see there are a lot of their Mini EV, Zen, Vigo Life, Mitsubishi, Smart for 2. It's a very small, only 2 people can ride this one. 2 people can travel in this. And Think City, Toyota Prius, and Honda Insight. These are all compact, very small, like 4 member can go. And even you can see this one mini, it is actually 2 people can travel. In the sedan class, that is SUV, GM Volt, Nissan Leaf, Koda EV, Toyota, Reva, and BYD E6 EV, and Ford Focus. These are all in sedan class. And in truck model, you can watch for it in the truck model. See Smith Electric Edition, Navistar E-Star, and Ford Transit, Mercedes and Renault Congo, and Bright Auto Idea. These are all in the truck model. So in every segment nowadays, electric vehicles are present. In every segment, electric vehicles are present nowadays. Okay, the planned electric vehicles, that means in future it will hit the roads. There you can see BMW, Volkswagen, Smart, ED, Volvo, Fiat, and Chevy Spark. They are all planned and they will hit in the future. Maybe in 1 or 2 years it may hit. And upcoming electric cars in India, even now India is also focusing towards the electric cars, and upcoming cars in almost all the companies in India, whoever all the players, they started developing their own electric cars. So Hyundai Kona is one of the one which is going to be released very soon. Maybe this year they will be releasing, I feel, in 2021. So you can see it has 395 Newton meter electric motor. Torque of the motor is 395, and the battery size is 39.2 kilovolt, and it can cover 345 kilometer per charge. 300 kilo. If you have a full battery, it can go up to 345 kilometer, and also the charging time, okay, you can see 80% of capacity it can charge within 54 minutes using the fast charger. So the point is charging time is becoming very late. Okay, if you charge the battery very quickly, then people used to buy it. Okay, people used to, but the cost, you see, it is 25 lakh. It is costly. Electric vehicle, the initial cost will be higher, but the running cost, it is going to be very cheap. And Tata also, they are releasing two models, Tata Tiago and Tata Tigor. I just run these places, and we will go to the our main topic. Okay, Mahindra EKU V100 and Mahindra XUV and Nissan Leaf, they are all going to be released in Indian markets. Okay, and planned upcoming electric cars are like Renault Kwid electric vehicle, and MG electric SUV, and Maruti electric vehicle. So these are all companies, they are planned, and they are able, they will be releasing in future. They didn't specify the specifications also. And you can see the parking present trends in parking and charging stations. So you can see this type of infrastructures in the foreign. Even in India, you can see the electric vehicle charging station instead of battery bunks. Okay, instead of petrol bunks, in the future, in 10 years or 20 years, you will find only electrical vehicle charging stations and battery changers. If you go to the bunk, you will have only battery. Just put your battery for charging, and you can take the battery for one which is fully charged, and you can just put in your vehicle, and you can just cruise away. So, and you can see in the foreign countries, this type of charger, whenever you go to work, and you can plug on with solar charging, and also with electric charging also you can plug on. So this facility, the topmost right hand side, this is in the Tata Motors has developed, because Tata Motors has released is going to release two electric vehicles. They already started electric vehicle charging stations wherever wherever they are going to release. And if you compare the market brands available at present, you can see the Ford Focus, Nissan Leaf, and its speed. You can watch for its top speed. And out of this one is a Tesla Model S. It is having the top speed of 207 kilometer, and the range. If you find a Toyota Prius, the range is you can say 870 kilometer in one charge. It is a very good. Okay, if you charge a battery, you can cruise in 870 kilometers. So this is you can able to find. Suppose you are want to go to buy an electric vehicle, your daily kilometer your coverage maybe like 30 kilometer or 40 kilometer, you can go for like Ford Focus. If you are a long traveler, you can go for the Toyota Prius, something like that. You can choose, okay, based on our requirement you can choose, but it is so costly. Electric vehicle are costly. Let us come to the types, okay, vehicle types. Pure battery operated electric vehicle, this is called BEV, battery electric vehicle. So battery, and you have a motor or generator, it can work as generator and as well as a motor, okay, and connected to the transmission through clutch or no clutch. Without clutch or no clutch it will be there, okay, with also gear, okay, gear arrangement. If you want like forward and reverse, only you will have two things, forward and as well as reverse, only two. Whereas if you find the conventional vehicle, definitely it will have like 1, 2, 3, 4, 5 and reverse. Okay, in case of the battery electric vehicle, you can have forward and reverse only. Two is enough. And you can see hybrid electric vehicle. So conventional electric vehicle, fuel, then a diesel engine or petrol engine, then the power is transmitted to the wheels. Whereas what is hybrid electric vehicle means, it is having a battery and you have a motor bar generator also there, and it can work and complete in fuel, that is a internal combustion engine also it can work, and it can work also in battery, and it can work in both, okay, that is both also possible. That is hybrid electric vehicle. Why you want to go for hybrid? Why you want to mix this battery operated electric vehicle and as well as the conventional vehicle? So why this is done is, see, the people, the manufacturers of conventional electric vehicle has put lot of money, crores and crores of money. They have invested in the engine technology and the chassis and as well as everything, transmission system. Everything is completely based on the in conventional engine. They have just put crores of money. But immediately, if you discard everything and you jump out to battery electric vehicle, and it is going to be for them, it is completely lost. So what they did is they developed a hybrid electric, that is hybrid electric, that means it is like, say for example, mini hybrid, okay, mini hybrid, macro hybrid and full hybrid, like that. They just evolving. Initially they just used battery only for the battery and the motor for only for assisting the fuel, assisting the engine by like just starting and stopping. So this starting and stopping can be for start stop mode. It can be used for the battery and the motor generator set combination. So then that is for mini, okay. So then they evolved into micro, macro and full. So full hybrid means, what is that? Full hybrid means that is it can run in, you can cut down in the engine and it can run in battery. That is run in battery means it can purely run as a battery electric vehicle. If you want, you can connect the engine. So that is what the full engine. So hybrid is, it is purely business, okay. Hybrid means it is because they don't want to waste the invested money, lakhs and lakhs and crores of money invested in conventional vehicle technology, that should not go as a waste. So they started with like mini, micro and macro, then full. That is, they are evolving into battery electric vehicle from the conventional vehicle. From the conventional vehicle, they just evolve into the battery electric vehicles slowly. For that purpose only, these hybrid electric vehicles are introduced. Classification of vehicles based on the path of energy flow, it is classified into the mechanical power transmission path. If you have only mechanical power transmission path, it is conventional vehicle, and if you have only electrical power transmission path, it is It's pure electric vehicle, battery electric vehicle, BEV. And if you have the combination, that means it is hybrid combination. That is mechanical power transmission path and electric power transmission path. If both is combined, it is called hybrid. So in hybrid, there are three types. That is series, parallel, and series parallel. What are they? Will let us check out. So what is series hybrid electric series means? Check out here. See engine, okay, engine, and it is connected to generator. See, it is connected to generator. That means engine is running the generator. It is used as a prime mover. Okay, then the power produced from the generator is stored in the battery, and the battery gives power to the motor, and the motor runs the transmission system of the wheels. This is series. Okay, this hybrid, it is electric series. Okay, let us check out the parallel. Okay, in this parallel, you see engine can also drive the transmission through the clutch and drive shaft mechanism, and motor is also can drive, and from the battery it can take the power. You can see the parallel. See the this path. Okay, this path is mechanical power flow path, this path. Okay, this clutch can combine. Okay, if this clutch connects, which the clutch connects with the motor, and it will be running. Okay, and this both can be coupled together, and it's can also be drive the drive shaft. So this is the difference between series and hybrid. So series and parallel hybrid vehicles. Yeah, you can see the series powerful engine, generator by converter, battery. So it stores the energy, whatever it is generated, it stores, it charges the battery. So the motor takes the power from the battery, and motor runs the transmission system. So and it gives power to the wheels. This is series. Parallel, you can see here. Parallel engine also can drive, and battery, the motor also can drive. That is called parallel. And in series parallel, you can just watch for it. If you want, okay, the series also possible. If you want parallel is also possible. Like that combination is done. Okay, that is engine. You see engine power is splitted. See, some portion is splitted for the transmission, and some portion is used for the generator. Okay, so that generator, what it will do is it will charge the battery through this inverter module. That is, inverter module can act as a charging also. It is a one type of mode where it can charge a battery. It can charge a battery. It is working with a lot of modes are there, like only what you call during braking. What happens? The power from the wheels is regenerated. Okay, in the generator, and it is stored. So like that, series parallel. So series power flow also possible, parallel power flow possible, combination is also possible. That is series parallel hybrid. And another type is fuel cell electric vehicle. This is also a latest technology. See here, the fuel cell is based on the hydrogen fuel. Okay, so hydrogen is used as the fuel. Okay, from the fuel tank, it gives the maybe the fuel tank may contain a water or a hydrogen, like, and it is given to the fuel cell. This fuel cell produces electricity. That electricity is converted to the converter, and it can charge the battery, and as well as directly it can run the motor, run the electric motor. Instead of battery, the fuel cell is working like a battery. Fuel cell is working like a battery. This is one more type. This is another type of electric vehicle, that is fuel cell based electric vehicle. So here you can have battery, or you can remove battery also. Without battery also it can able to run. But if the fuel, that is the hydrogen, is existed, that time you can use the battery as an alternate source. Battery as an alternate source for running the electric motor. Otherwise this battery is not required. The battery purpose can be provided by the fuel cell itself. And when you compare the internal combustion engine, then hybrid and electric vehicle, See, internal combustion engine, only 20% of energy stored in gasoline is given to the vehicle, whereas a hybrid it is 40%, because some of electric we are using, some electric power is also we are using, and some assisted running is done, so 40%. And when you check out the electric vehicle, it is giving 75% efficiency. Imagine, it is giving 75%. Only the mechanical losses only are there. Only mechanical losses in the sense like from the transmission system to the wheels. Only those losses will be available in the electric vehicle. And in case of the power converters, meager losses. And maybe in the battery also, like if you don't use the battery for a long time, the charge of the battery may go down. Okay, only those losses if you take into account, the remaining you can see only that is 25%. 75% efficient is electric vehicle. So only people are moving towards now electric vehicles. Okay, so this comparison I just go ahead because already we have seen. And what are the major components in an electric vehicle? You check out an electric vehicle, what are the major components? Is it electric motor, okay, then power converters, that is if you want to increase or decrease according to the motor rating. See, the motor rating, maybe it can work on 96 volt or 300 volt or 200 volt system. Electric motor you can design for that. What about the battery voltage? So this voltage can has to be increased or decreased, or it has to be converted. Say for example, if you use an AC motor, but the battery gives only DC supply, the DC has to be converted to AC. Those work is done by the power converter. And the power converter is driven by the driver ICs, okay, and you have an electronic controller. It can be microcontroller or microprocessor, which can drive the driver IC based on the feedback it receives from the car, from the wheels, okay, from the wheels and the sensor units. Based on the feedback, it can generate driving signals. Then that driving signals is given to the power converter. Accordingly, the electric motor is rotated. Suppose you break the vehicle, this motor will run as a generator and it will charge the battery. So that particular control is given by the electronic controller only. This electronic controller will decide whether to run as a motor or a generator based on the mode of operation. Okay, so this is the major components in an electric vehicle. So just a basic operation, let us check out. You can use AC or DC motors. And also you can watch for rechargeable battery is a must, and a power converter is also a must. So how basic operation of a DC motor? If you have a DC motor, okay, so you can go for 96 volt system, okay, you can even 24 volt system, 12 volt system. In a car you can find the batteries will be like 24 volts, okay, in two wheelers maybe 12 volt, okay, so 12 volt, 24 volt, okay, then you can go for 42 volt system. Any bad system you can try out, but proven is 96 volt system. It gives good power, so battery packs to be arranged to give 96 volt. Suppose 12 volt battery if you have, means you need to make it to 96. You need to make it 96, or else if it is array based batteries, okay, each cell can give you like 2 volt or 2.5 volt. That means you need to club to get this 96 volt. So how does this DC motor is controlled? It's very simple. If you press the accelerator, okay, this accelerator is a simple operation what we are talking of. This accelerator gives a potentiometer signal, okay. That means like when you press the accelerator, yeah, suppose you have potentiometer resistance value is changed, resistance value is changed. That value is read by the controller. Okay, then it says the controller decides what type of PWM signal I want to generate. So it is a DC motor works with a simple PWM signals only. That is, you can see here 50% on and 50% off. 96 volt. If you switch on and off at 50% off, on and 50% off, it is going to produce 48 volt. It is going to produce 48 volt in the output. So that 48 volt, if you provided through the power converter to the DC motor, such that the speed will be less. The speed for 48 volt, it will be running at lesser speed. Suppose you increase to 75% on time, 75% on, 25% off means you are increasing. So that means 48 plus 24 volt you are giving. That means 72 volt you are giving. If you give 72 volt to the DC motor, it will increase, the speed will increase. It is a simple armature voltage change. You change the armature voltage, the motor will increase its speed or decrease its speed. Accordingly, it is done by the accelerator. So when you press, when you press the accelerator, the pulse width is increased. When you release the accelerator, the pulse width is decreased. This is a basic control, simple basic control of a DC with DC motor. Similarly to with the help of AC motor also, you can go for changing the voltage. Okay, changing the voltage can be done, whatever applicable to the what you call the previous type for DC motor. And here also you can change the applied voltage to the AC motor, and you can change. And in AC motor, one more point is you can change the frequency also. If you change the frequency also, the speed is going to be changed. That is also another aspect in AC motors. So what are the modes of operation of electric vehicle or hybrid? Okay, if it is a hybrid and also electric vehicle, what are the modes? The first mode you can see here, electric only electric. Okay, that means battery and power converter and motor, transmission system, only battery. So this clutch, the engine is open, that means engine is not turned on, only battery. Okay, through battery, that is pure electric, you can turn on. This is one mode. And hybrid bar electric assist. So hybrid bar electric assist means engine is coupled with the clutch. Okay, the clutch is closed. Okay, engine is that is clutch is closed, and this electric assist means motor just assist the engine, that is internal combustion engine, by meager power, like 20% of the power it will be you taking. The motor may take only the 20% of the power, remaining 80% is from the engine. If you do like that, it is called a hybrid bar electric assist. In vice versa also you can do, like that is engine can be assisted with the motor. That is also possible. For that to do, the motor should have the higher rating. If the motor is very higher in rating, that can drive directly the electric vehicle, means no problem. The engine can take 20% and the motor can take 80% of the driving power. So that both vice versa can be possible. That is engine assist electric, and electric, that is engine will be assisted by electric. Both possible, two modes in here it is possible. And the other one is battery charging. So this battery has to be charged. Suppose the engine is running, okay, and the power, okay, is engine power is transmitted to the wheels through the transmission. During that time, this motor will run as a generator. This engine is running, this motor is run as a generator. If it is running as a generator, this power converter will charges the battery. This charges the battery, that is battery charging. Okay, so this motor will run as a generator, okay, that time. And in regenerative braking, that means you apply brake. When you apply brake, okay, you apply brake, what happens here is the power which is present in the wheels, okay, come back to the transmission, and the transmission is connected to the motor. So motor is also running. Now this motor runs as a generator, and here you see this clutch is open. This engine is decoupled. The engine is decoupled from the transmission system. Okay, so now we are braking, just we are braking. So when you apply brake, the engine is decoupled and the motor now runs as a generator and it charges the battery. So so during braking we use the power, we use the power for charging the battery. These are all the modes of operation of electric vehicle. Either it is pure or hybrid. If it is a hybrid, okay, so engine will be there. Okay, if it is a hybrid. If you cut down this engine, okay, if you cut down this engine, it is purely electric vehicle. If it's a purely electric vehicle. So in case of this electric vehicle, this mode will not be available. This mode, okay, this mode will not be available. So pure electric and regenerative braking. Okay, pure electric and regenerative. A and B will be there in pure electric battery operated electric vehicle, A and G. Whereas if it's a hybrid, you will have all four modes of operation. So Maheshwaran sir, is it clear? No issues? My video and audio, is it okay? Maheshwaran sir, or the organizers? Hello? Anyone can just give the feedback. That's okay means I will proceed, because I was just talking almost for 45 minutes. Hello? Hello?
Yes, sir, you can proceed.
Proceed, no problem? Okay.
Yes, sir.
Okay.
Sir, okay, sir.
Is it okay, sir? Everything? I can't hear you. Okay. Anyway, Sudan has given the feedback. No problem. Okay. Then let us come to the types. Okay. Types of electric motor. So the types of AC and DC already we have said. And AC, and under the AC motor it is asynchronous. There it is nothing but induction. And synchronous. Under synchronous we can have permanent magnet synchronous motor, then simple synchronous, then switched reluctance and stepper motor. Under PMSM you have two types, that is trapezoidal and sinusoidal type. And in case of DC you have self-excited, separately excited, under self, series and shunt, and separately field excited and permanent magnet excited. These are the types of the motor. So what are the motors used in electric vehicles from 1835 to nowadays? Okay, 1835 to now. You can see brushed DC motor, induction motor, and the induction is AC. Okay, brushed DC motor they used, and brushless DC motors. Okay, then permanent magnet synchronous motors, then switched reluctance motor. So these are all the main 5 motors which are utilized in day-to-day electric vehicles and hybrid. Whereas if you watch this brushed DC motor, they have a drawback of changing wear and tear of the brushes. So, and also it is a little bit bulkier, and this arrangement of commutator, all those things are there. So it is and also it produces heavy spark. So people nowadays not using this brushed DC motor type. And similarly the induction motor also they are not using. They use BLDC, brushless DC motor, and PMSM. These are all widely used. Let us see why they are widely used. Okay, these are all basics. Okay, induction motor, you compare the induction motor. It is lightweight, small volume, low cost, high efficiency. Somewhat okay, like 75% or 80% efficiency it can give. Okay, induction motor. Whereas what is the drawback? If you find out the synchronous motor, the torque is very less. The induction motor, the starting torque produced is less. So inferior in torque, that is the main issue. And similarly, its efficiency are also very less compared to the other types. And permanent magnet brushless DC motor and PMSM both comes with the same construction. Only BLDC is permanent magnet. BLDC is trapezoidal type, and only two phases is excited at a time, whereas PMSM three phases excited at any time. At any time, three phases will be excited in PMSM. Okay, so if you find out its applications, it is good, but the problem is its cost. The cost of the PMSM is permanent magnets is quite high, and it is also rare earth type. Okay, so rare earth magnets you need to take out, so that is a little bit costlier. And complex electronic commutation, so you need to make complex electronic commutation has to be carried out. That is another drawback in case of this type of motors. But if you see efficiency, it's very good. Efficiency is very good compared to all other and power density, it's also good. The drawback is cost. Okay, so then SRM, okay, switched reluctance motor. So this switched reluctance motor, no permanent magnet or coil at rotor. That is one advantage. But the torque produced by this particular motor is inferior, and also it has got more torque ripples. So the torque produced by the motor in the outside, it is very ripply. Okay, it is having oscillations in the torque. So that is it's the drawback of SRM. When you compare the advantages and disadvantages of induction motor, low initial cost, high power, high average efficiency, and lightweight. And a disadvantage, rotation slips from frequency and accumulation of rotor heat. The rotor heat is a big issue here. And switched reluctance motor. In this switched reluctance motor, low initial cost, its advantage, high average efficiency only, not good. Okay, and a very simple control, highly reliable. It is reliable, good. It is reliable that it will not have any faults, so it is reliable. But the problem is lesser disadvantage is less torque and torque ripples, and it is producing acoustic noise. And if you compare the PMSM and brushless DC motor, both comes with same construction only. That's why I have put here in the both. Only in PMSM it is sinusoidal flux distribution, and brushless DC motor is trapezoidal flux distribution. Okay, that is the difference. Otherwise, it is one or the same in construction. Okay, here long lifespan, least rotor heat because permanent magnets are present in the rotor, so no heat, and low maintenance, high efficiency because brushes are not there, so it is long lifespan is there. But the drawback is high initial cost, and this also produces this also produces torque ripple because it is commutated through inverter. Through inverter only you need to give supply. A DC supply has to be converted to AC from inverter. From the inverter only you need to give to the motor. So that means you switch on and off the power devices, it produces torque ripple. That is the drawback of the PMSM and brushless DC motor. So under the predominant, that is the old one, that is brushed DC motor, that is high maintenance cost, that is brushes often fail, and low lifespan due to high heat. But if you see the advantage, low initial cost and simple speed control. So that is when you compare all the motors. So now if you compare all the motors, the best motors is these two. Okay, that is PMSM and PMBLDC. These two are the best. Okay, these two are all the best motors. Okay, but if you see SRM, the point which it scored is 13.5. Okay, 1 point is little bit higher. What is because of his weight? Okay, if you see the weight, it is very less. Okay, the weight is less, but when you compare the efficiency, it is lesser. less. Okay, that is the another advantage of the SRM drive. But still, when you compare the other parameters, efficiency and weight and cost, if you compare, the highest score is SRM. And if you compare the other what you call parameters in the next slide, you can see power density, efficiency, controllability, reliability, and technology maturity and cost. You can see this BLDC and PMSM scored high because power density is quite high, whereas the power density of SRM is very less. Okay, power density. That means the power produced by the motor, okay, is less because the SRM doesn't have rotor is simple. Okay, it doesn't have permanent magnets. Simple iron. Okay, say simple iron is the rotor. So it doesn't produce extra torque. Okay, that is extra torque or extra flex. Okay, that is the point here. So this is very less. So this BLDC and PMSM are the quite good. Okay, quite good for usage. Whereas you see the induction motor here, it is scored 26 point because of the cost. You see, because of the cost is very cheap, so it got high points in the induction motor got high point because of the cost is cheap. But whereas if you see the power density and efficiency, these two are the best. So what you have to do is you have to go on this BLDC and PMSM for electric vehicles. You can also choose the induction motor and as well as SRM, but the best one in the technology wise and the power density wise, efficiency wise, they in the world they are choosing only BLDC and PMSM, brushless DC motor and PMSM. So this is how they do it. And when you compare the torque and speed curve, see speed torque characteristics. Okay, you just check out we at constant power. See, normally at constant power only the vehicles are going to be operated. When you compare, you see this PMSM at low speed, it can give high torque. You can just watch for it. The speed, okay, at low speed it can give quite a good high torque. That means at load, okay, like four people are sitting in a car, okay, if you want to start, and this is very good. So PMSM and BLDCs are very good. Okay, PMSM and BLDC are very good because at the low speed it can able to give you high torque, whereas if you see the induction motor, it is okay, it is not too bad compared to SRM. Okay, see, SRM is the least while giving the torque. Okay, that is starting torque. When the speed is 0, okay, the torque is going to be very less. And you can see an induction motor, yeah, this can it is okay, but whereas the PMSM and BLDC gives good, okay, good torque. And if you see the transmission characteristics, this is tractive effort. Tractive effort means the effort for running a vehicle. Effort for running a vehicle is called the tractive effort. So you can see first gear. Okay, first gear, the vehicle speed will be very less. Then you transmit for the second gear. Okay, after you go like 20 kilometer, you change to second gear, and then 40 or 50 third gear, and 60 and above you go for the fourth gear. So you can, if you watch the electric motor with single gear transmission, the black line, okay, this electric motor with single gear. Single gear means forward and reverse, that's it. Okay, forward and reverse, no first gear, second gear, third gear, fourth gear concepts. Just forward, you just put a forward and you can cruise. Okay, if you want to go back in the reverse, you can put the reverse. Okay, so this is the transmission characteristics of an electric motor is very good, very compared to the first gear, second gear, third gear, fourth gear. These are all likely manual shifting, whereas if you see electric motor, just put forward and just you can cruise out. And what are the forces on running an electric vehicle? If you are any simple vehicle, you see, if it is climbing in a gradient, phi is the gradient. If it's a climbing, air will resist. Okay, similarly tire, friction with the road. That is one. And the gravity will pull down. The gravity will pull down. Okay. So it has to overcome the tractive effort, that is the engine or the motor has to produce the tractive effort to overcome all these dragging forces. This dragging forces is this aerodynamic drag, air, okay, and then the rolling friction of the tire, and the force due to the gravity, okay, force due to the gravity. And also if it is a moving vehicle, m into dv by dt, that force also it need to overcome it. Sometime it may assist you while coming down from the hill, whereas if it is moving up, it has to overcome that effort also. These are all the sum of the forces in a vehicle. So according to the Newton's second law of vehicle traction, m into dv by dt equal to ft minus frl. What is ft? Is this is the tractive force, that is the force required to run the vehicle, ft, okay, and frl is oppositely acting, which is not allowing for the movement. What are they are? The uh, that is what are they are? Hill climbing force, that is gradient force, rolling resistance of the tire, and the aerodynamic drag. These are all the opposite forces which will not allow the vehicle to move forward. Okay, so it has to overcome, the tractive effort has to overcome that, and it has to be positive such that it to move in one particular direction. Okay, so R road load FRL. So and m is the mass of the electric vehicle, and v is the driving velocity of the electric vehicle. So Ft, tractive force Ft, is equal to FRL plus m into dv by dt. See, this m into dv by dt, it will be there only for vehicle when it is running. If it is not running, what can it will be? It will be dv is 0, velocity is 0, so ft is equal to frl at standstill. At standstill it will be same, whereas if it is moving, m into dv by dt will be present. Okay, so then hill climbing force given by mg sin phi, and mu rr, that is rolling coefficient, mg into m into g. So g is the gravity, that's 9.8. Aerodynamic drag half rho a c d v square. So v is the velocity and a is the area, okay, frontal area of the vehicle, and rho is the air density. Rho is the air density. Rho is the air density. CD is the aerodynamic force coefficient, and phi is the angle. Okay, hill climbing angle. So this hill climbing angle you can watch here. This is the phi. Phi is the hill climbing angle. Okay, so then some of the coefficients for different conditions, okay, different conditions, rolling resistance coefficient of tires for different conditions. So on concrete and asphalt, 0.013. Car tires are rolled gravel, and gravel 0.02. The gravel road, if you are running your vehicle, its coefficient will be 0.02. And tar macadam, it is 0.025. Unpaved road 0.05. And in a field means you run in a paddy field or any other field, you just simply do it, it will be like 0.1 to 0.35. Okay, and truck tires on asphalt 0.006 to 0.01, and wheels on rail, it is 0.0. These are all the rolling coefficient. Accordingly, you need to use for your tractive force calculation. So, and aerodynamic coefficient also, CD also changes type of the type of the body of the vehicle. See, van body 0.5 to 0.7, ponton body, you see, and when you have the streamlined body, it is less. You see, streamlined body, aerodynamic coefficient is very less. That's why you see the sports model and all comes with this type of designing, okay, the streamlined designing to reduce the aerodynamic drag. And also they used to keep very low to the ground, The very low to the ground means the aerodynamic drag is very less. So that's why you can find the sports cars are very low to the ground, and it will be aerodynamic in design to reduce the drag coefficient. And this is a simplified model for motor driving a tire. So whatever you found, this is tractive effort TL, but whatever you found, the FT, with help of this FT, when you calculate, okay, at standstill, what is the FT? So with that FT, okay, you can find out that is the TL, the load torque. The load torque, if you can easily find out by help of this formula, that is TL equal to FT into R by G. What is this? R is this is the radius of the tire, and G is the gear ratio. G is the gear, is it 1:1 or 1:2? Normally, for in battery electric vehicle, the gear ratio will be 1:1. Okay, so if you know the radius of the tire which you are going to couple with the motor, and it is simple, you can easily find what is the torque required by the motor, you can able to find, okay, by FT. If you know this FT only, you can able to find the torque of the motor. So this torque, no, by knowing this torque, you can design a motor easily. You can design a motor. So to design this motor, FT is required. So in almost now 1 hour 10 minutes has gone. Okay, maybe in future, maybe after 1 month, we can 1 or 2 months later, and we can have a designing, how to design a electric vehicle, that is motor designing for a electric vehicle. We can able to do one webinar or seminar. We can plan maybe after 1 month. Okay, because with 1 hour I just gave only the basics, how to come up with which motor to choose. Okay, and then bring it down, how to choose the FT, that is a tractive force. From the tractive force, you can able to find out the torque. So we can have the designing in the next webinar. Okay, maybe like that. If your organizers plan, we can do that, no problem. Okay, so then the best motor, just I will give you the comparison. Okay, I don't want to go into details, already we are running out of time. Okay, so you can see the rotor. Okay, the rotor of a permanent magnet synchronous motor and BLDC, a simple motor. You can see permanent magnets are pasted over the rotor, and other one with with screw also you can bolt the permanent magnets, that is also possible. And you can see other types of configuration. This is surface, the surface one only we have seen. This is surface type. Okay, surface type rotor, that is with permanent magnets. There are 4 poles, 1 2 3 4 4 poles. Okay, rotor poles. This is surface type, and the other one is interior. This interior type, you keep the that is magnet inside the slot. Okay, you keep the magnet. And in interior transfers, you keep your the magnet in this fashion, such that this is north and this is south. Okay, here the north is here and north is here, south. You keep the motor in such a way that it transfers. Okay, transfers. That means the flux produced here will be in this direction. Okay, that is the difference. Here it will be emitting this way. Okay, this is transfers. And based on the wave shape of their induced EMF, see, this is induced EMF, that means back EMF. So back EMF is sinusoidal, means it is PMSM. Back EMF is trapezoidal, means BLDC. How to make back EMF sinusoidal? That means if you keep concentrated winding, okay, that concentrated stator winding, if you keep, that is in one slot you keep 10 windings, and after say 4 or 5 slots, the first slot and sixth slot you wound with more number of turns, that means concentrated winding. Whereas sinusoidally you distribute, in the first slot you give 1 winding, in the second slot 2, and the third slot 3, like that you increase and decrease, like a sinusoidal distribution. That means it will increase, the conductor will increase in the slots, and then it will decrease. That is called sinusoidal distribution. Whereas concentrated means you just keep in one slot too many coils. Okay, too many coils in one slot means it's concentrated. So so you can watch the waveforms. Okay, there is a trapezoidal. Okay, it moves in trapezoidal fashion. All of a sudden the voltage increases and constant, and then all of a sudden it is decreasing. Whereas you see the sinusoidal distribution, it gradually increases and gradually decreases. So that is the difference. Okay, that means in sinusoidal distribution the smooth torque will be there, smooth torque, and whereas in trapezoidal all of a sudden it increases to very high and comes down. The current or voltage increases and comes down quickly. So what happens is torque ripple because of sudden increase and decrease. Okay, torque ripple occurs. So this is the cross-sectional view of the motor. It can be a PMSM or a BLDC, and you can see the rotor magnets, and this is the stator windings and the shaft, and you can see Hall sensors are kept in these places. Hall sensors. There are 3 Hall sensors are kept. Okay, to identify the rotor position. So this is a small what you call miniature rotor of the same. Okay, this is actual rotor. You make a same size, only the miniature size, very small rotor of the same what you call configuration. Okay, like a concentric circle. Okay, like a concentric circle, you reduce the radius of the concentric circle, you make a small what you call rotor, and that rotor has also how many poles in the rotor magnet rotor, it will have the same number of poles. Okay, that is also placed in the same shaft. What for this is given is to sense the rotor position. Suppose this Hall sensor senses the rotor where it is present. If you keep here, what will happen is the stator flux may also induce the Hall sensors. So Hall sensor works on the flux only. It senses the flux only. So that is the disadvantage. That's why we have a small motor. Okay, small rotor. You are making it is similar to the actual rotor. Very small. Okay, very small, which is placed in the same shaft to sense the rotor position. Okay, what for this Hall sensor is based on the Hall sensor data. You make a commutation. You make commutation because brushless means you remove the brush from the DC motor. What will happen? How to commutate? There is no commutator. You have to electronically commutate. That's the point. So to know the to electronically commutate, Hall sensors are very essential. Hall sensors, it senses the rotor position, and according to the Hall sensor data, we excite the stator windings. That is what this drive circuit. Okay, you can see here microprocessor or microcontroller interface circuit, and this is the inverter. That is the inverter circuit connect to the connect to the motor, and Hall sensors also you can see it is placed here. Okay, there are 3 Hall sensors. Okay, why these 3 Hall sensors means there are 6 devices are there, and also this inverter can work in 6 modes of operation. To choose any one mode, to choose, if you have 2 Hall sensors, you can able to choose only 4 modes of operation. If you have 3, you can able to choose up to 8. But this will work. This converter will work in 6 operating modes. So that's why we have chosen 3 Hall sensors. Yeah, you can see how does this BLDC motor work. So BLDC motor at a time only 2 phases is turned on. 2 phases is turned on at a time. Let us see here. You just watch here. 0 to 60 degree. You can see A phase is positive and C is negative. A phase is positive and C is negative. And 60 to 120, 60 to 120, and you can see A is 0 and you can see B is positive and C is negative. Okay, so like that, only at a time only two phases are on. One is positive and the other one is negative. One is positive and the other one is negative. And you can see the modes of operation: 1, 2, 3, 4, 5, 6 modes of operation. To choose any one from this, we require 3 Hall sensors. So that is the Hall sensor signals. You can see 1, 0, 0. Suppose one is for North Pole, one is for North Pole, and the other two Hall sensors experience South Pole 1, 0, 0. Okay, because one pole means 180 degree. Okay, one pole means 180 degree. You can see the next data 101, 001, 011, 010, 100. Like that, you can have the Hall sensor data. Accordingly, the mode is chosen, and its devices which are conducting also we can display, like 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and 6, 1. These are conducting devices. So that means it is nothing but these devices. Okay, so which 1, 2, okay, then 2, 3, okay, 1, 2 is one mode, 2, 3 is another mode, and 3, 4 is another. Okay, then 4 and 5, 4 and 5, then 5 and 6, like that. Okay, so now you come to the operation. Okay, now you see at this point, okay, 110. Okay, at this point all sensor data 110. At 110 means you excite accordingly to the windings. Accordingly the windings of you can see the C phase is positive. Okay, and also see the red color is positive. You see C phase, and then after that the green. Okay, after that the green. Okay, come back to the green, and this is negative, and come back. Okay, yeah, so that is the two phases turned on at a time. Okay, and you see the next case. At this case 010 and 010, you can see, okay, it is positive and that is negative. C phase is here positive and the other one is negative. And you can see the next one, it is changing. You can see A phase. You see here A phase becomes positive in this particular data, that 001. So you can see the continuous rotation. So based on the Hall sensor signals received, accordingly you excite the winding and it will be running like this. This is the BLDC motor working. Then PMSM, okay, permanent magnet synchronous motor. Here it works three phases. Okay, three phases on at a time. Okay, one will be top and the other two will be bottom. One is positive, two is negative. Like that, it is going to turn on at a time. Three phases is turned on. So what happens is our torque ripple is less in the PMSM motor. Okay, so let us see the first case. In this case, you see this blue. Okay, the at this place the blue is blue one is more positive, and the same time the red is negative. The red is negative, and the green is also negative. So more positive is blue. So now you see the blue. Now it is north. It is becoming north now. So what happens is south is attracted towards it, because this is north, so south is attracted towards it. Okay, whereas the other two are not what you call they are negative. Okay, so only this one is positive. This is for the first 60 degree, and the next, okay, next case you see here, red is more positive. Okay, that means this is north. This becomes north, and you see here the south goes very close to this north. So like that, the orientation changes. And the next case, and the next case, next case, and next case. So this is how it works. Okay, here also it works in 6 modes. This also works in 6 modes, but the change between that and this is it is having 2 phase on at a time is BLDC. Here 3 phase on at a time. Okay, so then you compare the BLDC and PMSM. Both are synchronous machines fed with direct currents, fed with sinusoidal trapezoidal back EMF, this is sinusoidal back EMF. Stator flux varies only each 60 degrees, whereas here continuous stator flux variation. So smooth torque is possible. Okay, only two phases on at a time. Two phases on at a time. Here, three phases on at a time. And the torque ripple present at commutations. Here, torque ripple will be there, but it is minimum. Okay, PMSM also, because switch on and off between the power converters. So whenever you turn and on off the commutation, electronic commutation is present. So torque ripple will be there, but smooth torque ripple, not like BLDC. Okay, so when you compare the motor control, BLDC motor control with PWM technique, and you can go for sensorless control, and whereas PMSM control, you can go for variable frequency control and vector based control like field oriented control and direct torque control also possible. With scalar based control we are not using. Okay, we have to go for field oriented control and direct torque control in PMSM. So with this, I feel it's enough. I feel it's almost 1.5 hours. I would like to give one more idea regarding challenges. Okay, major challenges in electric vehicle, and I will like to finish off. Okay, so what are the major challenges in electric vehicle is identifying the type of battery. That is very, very, very big challenging. Whether you go for lithium ion battery or lithium polymer battery or metal hydride battery, all those things you need to identify. Then what is the problems associated with battery? See, why I am giving this outline is any researcher available, you can work on these problems. Okay, a lot of people are working in these problems. So for any researcher, identifying the problem is a major thing. In which one I want to work? Okay, that is a big question mark people will have. So for a researcher, this slide will be definitely useful. That's why I just wanted to give you. So identifying the type of battery and what are the battery problem is it takes long charging time and it is more weight. How to reduce the weight and how to reduce the charging time? That is a big question mark in a battery. Some you people can work on battery. Okay, then distance travel in one charge. What is the distance travel? Okay, in one charge, whether 400 kilometer, 500 kilometer, or 600 kilometer, up to you to decide what is the distance travel. That is also you can able to work on it, and then starting torque. Okay, that starting torque in the sense PMSM and BLDC is going to give you good starting torque compared to all other motors which are present. Okay, so how to get more starting torque in that area also you can able to work on. That is also people are working on in that area, and designing of good controllers for motor without torque ripple. So smooth, okay, transition, smooth running, smooth cruising is required, but for that you need to work on the controllers, good controllers for motors. Okay, so then designing of chargers, quick charging for the battery, that is also required. Okay, you can just think of and you can work on in that area. And then the last point is identifying the coupling mechanism with the mechanical systems. So how to couple the differential gear arrangement or transmission system, whether it is a gear based type or a belt driven or a chain, all this thing also can be dealt on. But as an electrical engineer or a mechatronics engineer, you people can work on in this area. Okay, in this area also possible. Some sensors you can able to design for a betterment of increasing the efficiency of the electric vehicle. You can try on these areas. Okay, and these are all my references. Okay, and then any queries, floor is open to all. Maybe 5 minutes I can give you for queries. Anybody is having query? Okay, I will just finish off with one small thing I have for you. See, this is I will show a small simulation of brushless DC motor. Okay, in this brushless DC motor, I asked at 0 time 10 Newton meter. Okay, and at 2 seconds I am asking 8 Newton meter. Okay, that is my input. Okay, that is my reference input of what I want. A control system. I design a control system to give you my 10 what you call Newton meter at 0, and at 2 seconds 8, and at 4 seconds 6. Okay, then 6 seconds 5, and 8 like that. Okay, I have given like that. Let us check out its result. Okay, it is like completely open loop. Okay, this is a completely open loop. Okay, let us check out. Yeah, so this is the speed. Okay, what is the speed I have claimed for is at starting I want 400 rpm, and 2 seconds I am increasing the speed 600, and then 4 750, and then at 6 900, and 8 1050, like that I am increasing the speed. Okay, now let us check out the result of the simulation. Okay, you can see at 0 I want 10. Okay, but it is oscillating. Can you see the oscillations from 8 to 12? Okay, it is oscillating. So just wait, I'm just zooming my x-axis. It is oscillating. This is the torque ripple. This is what I just wanted to show you, the drawback of the motor. Okay, so it's error. Okay. Okay, no, it's completely closed. Okay, anyhow, I have showed you what is the drawback of the motor. Okay, yeah. So the drawback of the motor, you can see I asked 10, but it is oscillating between 8 and 12. So it is a very big torque ripple. Torque ripple is present in BLDC without any control system. If you design a good control system and you can minimize the torque ripple, if it can oscillate between 10.4 and 9.6, it is good. 9.6 to 10.4, if it is oscillating, it is good. So people can work on in this area also. Okay, so with this I cover up. I feel I have covered up because the time is very short. Okay, the floor is open for questions. If no questions, we can wind up.
Thank you, sir, for your valuable and informative speech. Now it's questionnaire session. I request the participants to post their queries in the chat box for discussion. Sir, I can ask you the participant question, sir.
Okay.
The first question is from Manish Pandey.
Okay.
What is the advantages of electric vehicles in future?
In future, so see, first one is efficiency. Okay, efficiency of the electric vehicle is quite high. It is almost 70%, 75%. It is giving efficiency. So in future, if you find after 10 years or 20 years, only electric vehicles will be roaming in the streets. Maybe after 20, 30 years, you will not find the conventional vehicles. They will die out in future, because global warming is a very, very big concern. So if you find the last 100 years data, we are now 2 degree increased. The global temperature has increased to 2 degree compared to the last 100 years back and now. And nowadays, day by day, the pollution level is going up. You can also think of the Delhi. They have banned all those what you call conventional vehicles, and they have given CNG based transportation vehicles. Okay, CNG, the natural gas based transportation systems are only used, and only in the car segments, and the people and the two wheelers only they are using the conventional vehicles. The complete transport that is for what you call public transport, they are using only CNG based systems. So what is the advantage in the future is it is going to rule. It is after 20-30 years, if you find only electric vehicles will be present. If you see the Telangana state, now they have given a good offer that there is no road tax for the first 3 lakh registrations, like that I have just gone through. Okay, so nowadays government itself claiming to go into electric vehicle. They want the people to buy the electric vehicle and they just wanted to move because of importing cost of the fuel that is quite high. Okay, that's it. And next question. Hope I have answered the question.
Yes, sir. Hope we have cleared all your queries. Now we have posted the feedback form link in the chat box. I request all the participants to fill the form and you can receive your e-certificates to the registered mail ID. I'm happy and I'm sure that all the faculties and students who joined this webinar from NIET and other institutions had a great day. First and foremost, I thank Almighty God for showering this blessing for this program. I thank our most respected and honorable chairman and managing trustee, Advocate Dr. P. Krishnadas sir, in his absence here. I thank our most respected and beloved CEO and Secretary, Dr. P. Krishnakumar sir, in his absence here, for his continuous motivation and encouragement. I thank our respected guest speaker of this webinar, Dr. B. Adhavan sir, for readily accepting our invitation. Thank you, sir. I thank our beloved principal, Dr. P. Maniyarasan sir, who is the driving force for us to perform and excel in all the work. Thank you, sir. I thank our respected head of the department, Dr. S. Selvam sir, who is the backbone for organizing and conducting this webinar. Thank you, sir. I thank all head of department, faculty, and staff members of NIET and MGI family for their continuous support. I thank all the participants from various organizations for your active participation in this webinar. I thank you one and all. Thank you.
Okay, thank you very much. Thank you very much for the opportunity given. I thank the management of the Nehru College team and the principal, HOD, various department HODs and mechatronic department HOD, and my friend and associate professor Dr. M. Maheshwaran. Thanks for the opportunity given. So with this 1.5 hour time, I have completed. I feel I have given an just overview. See, electric vehicle is a big ocean. I have just given a small overview, like in a ocean. I have given a cup of tea or a coffee. You people can explore. You people can explore in electric vehicle. There are a lot to be done. There are a lot to be done, and our knowledge is also very limited. So my knowledge is limited to the choosing of the motors for the electric vehicle. Okay, so thank you one and all for the opportunity given to me. Thank you once again. I thank you all. Thank you very much. So I am leaving the session, Kana. Sugan, I am leaving.
Yes, sir. Thank you, sir.
Thank you very much.